All right, I will ask for if they have a color proposal then. All right, so let's go back to the 3-1 note. Where we left off last week, we were going through how to actually calculate R. And I said, I know your calculators do this for you. You can enter all your ordered pairs, and you just press a couple of buttons, and you have the correlation coefficient. But I had mentioned that I felt that as AP statistics students, you really should have some sort of an idea where these numbers are coming from. But there are two different formulas, and I want to show you the other formula today. Now this one is actually called the computational formula. It looks pretty crazy, but once you got these totals up here, it really wasn't that bad, okay? So I like to go through the example in the calculator. A, practice in the calculator. B, I like to show you this visual, and I think I mentioned this, I put a star by it. All right, whenever you have once we start putting in our trend line, and that'll happen in section 2, your trend line will always go through the ordered pair X bar, comma, Y bar. Now the other formula I'm going to have you work with today, this is actually the one that's on your formula page. If you look at your packet of your formulas and your tables, this one is on the very first page. So that is even the one that apparently the College Board feels that you ought to be more familiar with. I will be honest with you, I have never seen it where you had to use this formula on the AP exam. However, this formula I think is good for showing why R is or is not resistant, okay? And we'll talk about that after we go through the example. So we're going to be using the same data that we had in on Friday. Now, if you still have your data in, that's great, but just keep in mind, I don't know if I still do. Do I have? I do not. I got rid of it because the issue is every time you go through and do like a one variable statistics on the Inspire, it starts making your list of variables get longer and longer and longer, and I didn't want that. So I wiped my data out, I think, on both of my calculators. I did, so I'm going to put it back in. So this is the same data that we used on Friday. The only thing that we did here was I had these listed side by side here, whatever. I have gaps in between here, and I have a reason for that. So, all right, I'm going to put these in. 0.35, 70, and 1. All right, and we have an n size of 7. So if you got rid of your data, put it back in, and even if you hadn't gotten rid of your data, maybe, like I said, for me, especially on the Inspire, how it keeps making that list of variables longer and longer and longer, I like to clear it out and start over at times. All right, so I'm going to call this one AU again, as I did the other day. And then this one, I called it D for density. Really probably shouldn't have, because the other one could be D for distance, but whatever. As long as I know. Okay, got them in. So what you'd have to do for this method is we're going to find our z-scores, okay? Now, this is another place I said this did not copy correctly. We don't necessarily need to write all these down here. Okay, so this will be done in your calculator. This will be done in your calculator. This is going to be done in the calculator, okay? So I put it there just so you kind of see what we're doing, but so what we're going to be doing is we're going to be calculating a z-score. So I had this in my L1 or my column 1, and again, I have it called it AU in my Inspire. I had this in L2 on my 84, and I called it D on my Inspire. I'm going to create an L3 and an L4. And I'm going to call this column ZX, and I'm going to call this column ZY. And basically what I'm going to do is I'm going to create formulas that I'm going to calculate the z-scores for all of these from their data sets. So you know the formula for a z-score, at least I hope you do. Z is the x value minus the mean, call it x bar, divided by the standard deviation, call it SX. So that's what I have down here. Is the first thing you would have to do is you would have to do your one variable statistics to get your x bar and SX out of here. So what I'm going to do, and I'm going to do what Michaela pointed out last week, I'm going to do stat. I'm going to do two variable statistics, and I'll do L1 and L2. And I can get my x bar was about 1.6, and we knew that because we used it on Friday. SX 0.97. Y bar, I'll just keep scrolling down, 4.3 approximately. And standard deviation for Y, we'll call it about 1 point, I guess it's about 1 point, I'll call it 1.02, so we actually have like a decimal going there. So when I set up my formula, in order to create all of these values in L3, I'm going to go back into Edit. I'll go to the top of L3, and I have to write the formula. But now don't forget, you got to use those parentheses in the numerator. So I'm going to tell the calculator that I wanted to take every value that's in L1. I wanted to subtract the mean, which I know is 1.6. Close the parenthesis, and I want to divide by the standard deviation, which is 0.97, and those are now all my z-scores, which when you look at them, hey, you know about what z-scores should look like, kind of anything from -3 to +3 typically. So when I look at those, I feel pretty good about that. Okay, those look like they could be z-scores. Okay, so I could fill in all these blanks if I wanted to. I'm not going to take the time because that's really not what I want. Okay, I'll get there. So now I'm going to go to L4 and I'm going to do the same thing, but in L4, I'm going to do, I want you to make a formula with parentheses, and this time I want you to take all the numbers that are in L2, subtract that mean, which is 4.3, and divide by that standard deviation of 1.02, and those are now all my z-scores for these. And let me get my Inspires caught up. So I'll go to the tippy top of this column up here, and I'm going to call this ZX. So Z scores for my X coordinates, and equals to tell it I want to do a formula, parenthesis. I want everything that's in my AU column, so variable AU, minus the mean was 1.6, parenthesis, and then divide by 0.97. So those are all my z-scores for my x values. And then I'm going to go to the tippy top of the next column. I'll call that zy. In the formula bar, I put an equal sign to tell if there's a formula coming. And it's all blurry again. I don't know why it does it for the Inspire, but whatever. Parenthesis. I want what's in the column called D minus that mean was 4.3, close the parenthesis, and then divide by 1.02. There are my z-scores. So what I'm doing is I'm going for this formula right here. Now, I don't know how much you looked at that formula, but literally that's all this is. Those are the z-scores for the x coordinates. X minus x bar divided by the standard deviation. That's all this is. Those are the z-scores for the y coordinates. So what this formula says to do is take all the z-scores and multiply them together. Okay, I'm going to make another column. And I'm going to call this one, I'm just going to call it ZXZY, because that's when I'm going to multiply everything together. Equals. So I wanted to take the ZX column and multiply by the ZY column. So variable ZX times variable ZY, and I would just multiply them all together for me, so I don't have to do it all by hand. And then I can do the same thing here. I'll go up to the tippy top and I'll say I want to take everything in L3 and multiply by L4. Done. So we have all of these in the third column. We have all of these in the fourth column. We've multiplied them together in the fifth column, what I just called ZXZY. But what I really need is the sigma of all of that. I need all of these numbers added together. Okay, so this again is where some people get confused. We're going to do one variable statistics off of L5. So I'm going to exit out of here and do one variable statistics off of L5. Now, this is where people get confused. The calculator calls everything X. So when I look at the results here, it's calling everything X. But I know that it's actually this column because I told it to do L5. So if I want the sum of that column, I want what they call sigma X. So it would be negative 5.607 approximately. Now, by the way, if you want to avoid round off error on that, 84s, if you press your variable button, you have a statistics menu. And you could say, well, I want the most recent sigma. I want the most recent sigma X that you gave me. And just to confirm, there it is. And then we want to divide by n minus 1. And our n was 7, and minus 1 is 6, so I'm going to divide by 6. Negative 0.93. So R equals negative 0.93. Now on the inspires, and there's our product column, we would need to do one variable statistics off of what I call ZXZY. Menu, statistics, calculations, one variable statistics. I'm doing just one list right now. And that list would be the ZXZY list. And there it is. There's your sigma X right there. Now, you guys, inspires, if you want to pull that value out, here's the problem. When you press your variable button, okay, and I'm just going to go to a calculator page. I think I need to. So I'll just go to calculator page, variable, look at your list. Okay, you have a really long list now. As soon as you start doing any sort of calculations, it's storing all sorts of stuff. You really have to search to find the right one. I'm going to go for this one. Let's see what that says. Okay, that's the one. And if you've done multiple calculations on an Inspire, that list just keeps getting longer and longer. There might be multiple sigma X's that you might have done a sigma X off of different columns. So you always want to confirm and make sure you found the right one, and then you could divide by 6 and you'll get the same answer, okay? So in terms of the math, you end up getting the same answer. We got the same thing yesterday with the other, or Friday with the other formula. Now, why was this one a little off? This was probably worse because we had rounded a lot of these columns when we added, and we rounded the numerator, we rounded the denominator. This had a lot of rounding. This one that we just did now, we didn't round anything. Oh, yeah, we did. I rounded those. You got round off error, no big deal, okay? Now this one here, the interesting visual, it's the same visual that you would have had on Friday. The only difference is because now that we've converted things to a standard score, instead of drawing a vertical and a horizontal line at the mean, you've now converted everything so it's centered at 0. So you would draw your vertical line at 0, you would draw your horizontal line at 0, and if you plot the ordered pairs of your z-scores, okay, I have them actually written down from last year. There's my first ordered pair. If I plotted that ordered pair, it'd be negative 1.3 and about 1. So negative 1.3 and 1. The next set of ordered pairs for my z-scores would be negative 0.9 and positive 0.9. Negative 0.9, positive 0.9. Now I'm not going to sit and graph all of these, but you know what picture it's going to make? It's going to end up making the exact same picture as the one on the previous page. Because the one on the previous page were the actual x and y coordinates. These are the same x and y coordinates, but converted to z-scores. Okay? It's going to give you the exact same picture. And at this point, because everything was standardized, you're going to end up getting your trend line would go right through here, which would be 0, 0. Because you standardized x and y and put them both at a center of 0. Okay? So why does the College Board give you this formula and not the other formula? Go back and think about the mean and the standard deviation. Okay, whether you're talking about x or y. The mean and the standard deviation. Resistant or non-resistant? Do they resist outliers or do they not resist outliers? They don't resist outliers. They're the ones that as soon as there's an outlier, there's a tail, the mean is like, ooh, I want to go out now. Okay, he can't resist the outliers. The mean is non-resistant. It can't resist an outlier. The standard deviation is calculated using the mean. So since the mean is non-resistant, the standard deviation by default is also non-resistant. But if they're non-resistant and they've been used now to calculate R, guess what? R is non-resistant. So R is non-resistant. An R value will be significantly impacted by an outlier in a data set. And it all comes back to the calculations. If X bar is non-resistant and SX is non-resistant, then R is also non-resistant, okay? And I don't think I've ever pointed out on the formula page. You do have, it does have formulas for your standard deviation, in case you ever forgot, okay? So there's your standard deviation formula right there. If you remember, we did a table, we did X minus X bar, and then we squared those, we added them up, we divided, we took a square root, okay? And I point this out only because it might help you remember that if you can remember that the mean is non-resistant, well, the standard deviation is calculated using the mean, so it becomes non-resistant. And any other formula that uses those will also now be non-resistant. It just snowballs, okay? So, summary here. The correlation coefficient measures only strength of a linear relationship. Always graph first. If your graph doesn't show a linear trend, you shouldn't even be doing R. Shouldn't even be doing it. Correlation requires that both variables be quantitative. Okay? If they're not quantitative, you can't have ordered pairs to graph. Correlation makes no distinction between explanatory and response variables. You could reverse the X and Y coordinates and you would still have the same R value. That is the other benefit of this formula. Do you understand that if I had just reversed these columns, all it's going to do is reverse the multiplication, but you know you can multiply in any order and you're still going to get the same answer. So when you go back and think about that, one of the very first questions, I said, how do you know whether you put the SAT or the GPA as the X or the Y axis? If you're doing correlation, it doesn't matter. Okay, it won't matter. You'll get the same correlation either way. The correlation coefficient has no units. It goes back to the fact that z-scores have no units. And if z-scores are used to calculate it, R can't have any units either. The value of R will not change if you change the units. Okay, so we measured this distance. It was something called an AU. I don't even know what that is. Let's say we, instead of distance AUs, we did miles. It won't change the R value. It's just going to change these to put them on a different scale, but the relationship between these two things won't change because they'll still make approximately the same graph. And I already talked about that. So this thing here, this was another thing I didn't copy correctly. There was a graphic that went with a quote that went with that guy. His name is Randall Monroe. Okay, so Randall